All right, hi everyone. Thanks for coming to our talk today about Velociraptor. So I don't know how much you guys heard about Velociraptor. The project started, I guess, in 2018. I'm a developer on the Gold Coast, and I used to work for Google and came back to Australia in 2018 and started working on this Velociraptor. So it's been around for a few years, and I've been talking about it in various conferences at OSCERT and at the OSCERT conferences and CrikeyCon and B-Sides, and so it's around the place as well. And in the last few years, it's gained a lot of traction, and a lot of people are using it. And so I wanted to show you today a little bit about why you'd want to use it and how it makes IR a lot easier. So the actual talk here is sort of a cut down version from the OSCERT workshop, which was a 4-hour long, hands-on type thing. So it is supposed to be kind of hands-on, but you guys can do it a bit later, or I don't know if you are going to do it hands-on today. If you are, let me know so we can walk through it. But what I'll do is I'll work through the examples, in the talk today. So it's not going to be a big death by PowerPoint slides. It will be. I'll have some slides and then we'll work through some cool cases. But if you have any questions or any comments or anything, just shout out. Don't be shy. So we're going to look at some scenarios, and then I've got here a slide here, just covering some of the prerequisites. Really, it's just a virtual machine, and we're going to be working with Windows. And you can just download a free VM from Microsoft and play around with it. As long as you have administrator access, then you can install stuff, and then we can do some low level stuff. And then over here there is a link to some scripts for setting up some of the exercises, but I'll link to them a bit later as well. So what is Velociraptor? So the idea with Velociraptor is to have an open source tool that helps DFIR. DFIR as a field, there's lots and lots of different tools, and they're varying quality. Some of them are quick Python scripts, some of them are, more elaborate C# tools or whatever, parsing specific artifacts. Some of them parse lots of different artifacts. And the idea was to actually create a framework that allows us to essentially implement all of these parsing frameworks, these DFIR techniques in one tool that makes it easy to deploy to a lot of machines at once. And really the I guess killer feature of Velociraptor is having this query language. And the idea is that using this query language, we can put all these capabilities together and create new kinds of capabilities. And we're going to see today how that works, but we're not going to go too much into the query language, but just to get you to appreciate that the flexibility of the tool comes from having this query language. And the idea is that with VQL, we can write these custom artifacts. We're going to go into that as well to just show you how we can customize and have a flexible detection and collection type capability. And finally, Velociraptor is used at scale. So we can hunt for these forensic artifacts at scale, 10, 20,000 endpoints in minutes, right? So we can basically say, who has files with which match this particular ERA signature, or or processes that have a particular thing. We're gonna see some of these examples. So that was kind of like what we wanted to do, that little, Velociraptor on a shark type thing. That's very cool. So just as an overview, the way that it normally works is we'll have a Velociraptor server normally deployed in a cloud, but you can also deploy it on-prem as well, and then have all the assets with the agent installed on them. So we can have Windows assets, Linux, or Mac, and then they connect back to the server. Now the interesting thing is that the communication protocol that it is persistent. So it's not like a polling type of connection. And having a persistent connection is really cool because it means that when you task that endpoint, it just does it. Like, you don't have to wait. In a lot of other tools, they have this polling thing where you can schedule stuff and then it polls every 10 minutes, and then and it's very frustrating when you need to do IR and then the thing is like, very, there's a lot of latency, really. So we have a persistent communication, so we can really kind of be very quick about the way that we're pulling it. And then we have an admin UI, which we're going to play with today. And that's how we kind of control the server with a browser-based interface. So that's kind of like a high-level overview. So typically, we support all the common operating systems, even FreeBSD and things like that. But the real interesting thing about the way Velociraptor works is that the server is very simple. Well, it's not very simple, but it does very little, right? Because we have this capability to run queries on the endpoint. So most of the analysis and parsing are all done on the endpoint. So the server just receives the results and writes them to the disk, right? So it has very little dependencies. We don't use a database. We just use files, right? So then we can. So it basically scales, right? Because the server doesn't really do all that much. Just collects the results and writes them to disk. So that's why it scales to typically. We say 10 to 15,000 clients on a single server is the recommended size. But we've had people running at about maybe 20 or 30,000, even sometimes up to 40,000 on the same really big beefy server. But I wouldn't recommend that. But we can go up to 150,000, and we're working on scale as well. Even above that now. So okay, so what we're going to do today is we're going to just for you guys to have a bit of a feel to how it works. We're going to install it locally. So when we install it locally, there is a way of essentially running one local server and one local client on your own system, so that you could, see how it feels like. And it's exactly the same as the other thing, but the installation is somewhat simpler. All right, so all you have to do is to just download Velociraptor and run this command, Velociraptor GUI. So that's what I'm going to do now. So, by the way, these slides are available on the website as well. So, I'm going to look for GitHub Velociraptor, right? And we're just going to go to our GitHub page, and you'll see down the bottom here there is a releases page, and currently the release is 0.65, and that changes as we make new releases and new features and so on. But you'll see that down here we'll have a bunch of different downloads that you can have, and you'll see they're usually like 0.65, then Linux, Windows, Mac, so they're like the operating system, and then the architecture. So Linux AMD64 is what you would typically run on the server, and or the client. So what we're going to do today is just download the Windows AMD64 one. So we'll just download it like this, and you'll notice that it's just an exe file, and so the exe file is a single executable that does everything. So it does the server, the client, all the administration tools, everything is done with one executable. So you don't really need to install anything else. That's really all it is. And then what I'm going to do is I'm going to start a command prompt and run it as administrator. Okay. All right, and I'm going to go to my downloads. Downloads. Okay, and this is the file I just downloaded now. And when you just run it, you can just, so it's not like, you don't really have to install it. It's just a file, an executable. When you run it, it will basically print some help. And you can see that depending on the command that you give it, it does different things. So it's just single executable that does lots of different functionality. But for today, all we have to do is just do a Velociraptor GUI, like that, and it will just start up, and then it will essentially start a server, and a client that works with it, and you'll see that it will open a browser, and it's kind of, when it runs in this mode, it's like a sort of a demo test type setup. So it has a hard-coded username and password, with the server is listening only on the local host, so it's only for local use. But other than that, and of course it has admin, and password is password, so it's like a local thing. But other than that, it's exactly the same as what you would get in a proper install. Of course, in a proper install you have better security than that, and you can use SSO and these kind of two-factor and all this sort of stuff, right? But for this exercise, we're just doing like a local demo. So that's all it is, just to bring it up. That's kind of one command, and it runs in sort of demo mode, I guess. Installing it properly is not much different. It's like maybe a couple extra steps. Very, very easy, and you don't really need dependencies. Like, you don't have to set up a whole bunch of databases and backends and all this sort of stuff. So it's very self-contained. All right, so what I'm going to do is, let me just quickly go through. So that was our release page, and what we're going to do in the first instance. So this is basically what I just make this a bit bigger. Right. So you can actually use different data store directory to store like the files and so on. This is what I mentioned. So it starts a local server on the local host. So what we're going to do now is we're going to go through the GUI. I'm going to show you just generally how to use it, as just a quick tour of the GUI. So when we start off, this is like the welcome page that we get. And the first thing that we do normally when we do IR is we have to search for the client, for the endpoint, and normally we kind of want to interact with it in some way and investigate it. So the first part of the GUI that most people use is the search screen, and if you just click that, you can either click the show all part or just click that. Then this is the search capability. So right now, because we started the demo kind of setup, there's one client which is on the same machine, right? And so we can see just the one client here. So we see the host name, the OS, the client ID. In Velociraptor, the client ID is how Velociraptor identifies all the clients using this random ID. So there's no really any registration or anything like that. Essentially, once you deploy the client, that then automatically registers and appears straight away in the GUI. So you don't really have to pre-configure them in advance. And normally what we do is we create an MSI and we just push it out through whatever solution, usually SCCM or something like that. And then off it goes, and it will install on all the endpoints and just suddenly appear in the UI. It's very simple, right? So there's no preparation you need to do. If I click on that client ID, then I can see this is down here on the left, we've got the different pages. This is the host information page, which just shows me general information about the host, like the client ID, the version, these kind of things. So let me just quickly show you the VQL drill down. So in this page, so that was the overview. In the VQL drill down, I can see this graph here, which is the memory and CPU footprint over the last 24 hours. So what we do is we always stream back telemetry about how much load that the client is imparting to the endpoint, because it's really important to make sure, because these things are on all machines, and we're really conscious about the amount of resources that we are taking on that endpoint. We don't want the CEO to call us and say, hey, my machine's just ground to a halt because you guys are doing IR or whatever. So if there's any complaints, then we have constantly telemetry of what we were doing on that endpoint at any time, how much memory we're using and how much CPU we're using, and we just collect this telemetry. So you can just basically see this is now what we're doing now, and memory use is 70 megs, and CPU is like 0.4% or something like this. But so it's something around like that. But it depends on what we're doing, right? So if we're doing like a very expensive hunt, then it could go up. So we are always very conscious of that, and we'll see later on that we can limit these resources and control them, in special ways. And then we just get like some general information here about like, IP addresses and things, active users, these kind of things. So this is just general stuff. You can customize it as well, and now over here, the next thing along is the shell. So I tend to not use it that much, but sometimes in a DFIR it's very useful to just essentially, pop a shell on the endpoint and just run some random stuff, PowerShell, whatever. It's not the best idea because it's not super controlled. Like if you can just go rm-rf/ and it will just do it, right? Like, so it's not like super, you can mess it up, right? Because you can write like some dodgy, mistype or whatever, right? So we don't recommend that people use it like as a, everyday thing, but it's sometimes very useful, just especially, when you have a dynamic situation unfolding. So in this example of the slide, I've got, let me see. So we showed that. I've got, here. An example, get local group member, get local group member, dash group, administrators, and that's a PowerShell command to list the local administrator group. For example, like sometimes the threat actors add themselves to the local admin accounts on the machine. So this is just an example, right? And you can always write like your quick little PowerShell, but I'll show you later how we can, add that into an artifact so it's more reusable and more controlled and things like that. But this is basically like just a shell. You can just write a lot of commands. We just kind of like hide that so that we could see if there's a lot of things that are more visible. But you can basically show that, and it's telling us who ran it, when did they run it, that kind of thing. So it's kind of handy to have just a quick shell. And over here we can use a number of different shells. On Linux we can have bash, things like that. So that's cool. If I just go to the home page here, which is the home page, so that's the dashboard of the server. It's just telling us in general, it's just some information about the server. So the server's memory, server memory use, and CPU use, that kind of thing. How many front ends we've got, these kind of thing. And then over here, it's telling us how many clients we have connected at this moment. So it's kind of changes with time. And how much disk space is left. So this is just general purpose, and then these are list of users on the server and their permissions. So you can actually also have different users with different levels of access. So for instance, you can give, and sometimes with when we do IR for consulting, then sometimes the security team of the customer, they want to know what we're doing. But we can't really let them drive it because they don't know Velociraptor, but they want to know that like we're not doing dodgy stuff with their network, right? So we can give them read-only access, so they can see what hunts are done and what collected and everything, but they can't launch new things, can't launch new like that sort of thing, right? So we can have like read-only access or administrator. There's different levels of access. So that's basically the UI. And then normally what we would do is we would sometimes want to interactively fetch files from the endpoint. And we have a special thing for that. Let me just go back to the host view. So we've gone through all of these ones on here. And then over here we have the VFS which is the virtual file system. And I'll just talk about that now. So if I click on that, then it shows us like a directory tree, basically, something that looks like a directory tree. But if I click on any of these ones, then no data available. It's kind of empty. Oh, by the way, before we continue, we can change the theme, so we can have different colors, right? So that's what we've used so far, is the default one, which is kind of boring. But we could change. That one is, I like this one. It's kind of clean. Or we have some dark ones. So I think this one is like very dark, right? Because it's super dark, and I actually really like it. But some people think it's too dark. So let me just show you back onto the, like these kind of things. It's very flat and dark. I like it. But that's not for everyone. These ones are a bit better. They're dark, but not so dark. But my absolute actually I've got two absolute favorites. This one is an N-curses one that was just added in the last version. See this open source thing, people just keep sending you crazy stuff. And I'm like, well, this looks really cool, but I just cannot imagine working with this, but it looks cool. So I'll just have it on for 10 seconds. I'll be like, wow, that's cool. And then change it, So the one that I actually really like is this one, which is very pink. But after you get over the, oh my God, the pink, then it's actually nice. It's actually quite a good theme. I actually really quite like it. I'm actually tempted to continue on with that. Yeah, let's do it. So yeah, I actually have that running all the time. I do like it. So VFS. So this is the VFS, right? So what is it? So it basically shows us, but actually might not be as visible on the projector. So I'll change that to. I'll change it. What do you guys reckon? They're really dark? Yeah. That's a little bit easier to see, I guess, in the projector. And also we have languages now as of the last version. So if you want it in any other, Japanese is kind of cool. So I have no idea what it's telling me, but it's cool, right? But I think it's really cool. That's, people actually are contributing these things. It's cool. Yeah, let me just go here. Okay, so we'll go back to English. All right, so this VFS view is essentially a cache of what the server knows about the file system on the endpoint. So we're not really looking at the endpoint directly, because remember that the endpoint may not be always connected. You might be off, right? It might be not online, right? So what we do is we fetch the directory listings and then cache them on the server, and then that UI views it. So the first time, the server really has no idea about the directory. So when we click on this button here, that refreshes, that directory here, and then we can see, it's got C drive and D drive, and then we can, go back here and refresh it again, and then it opens up another directory, and and in here, we refresh it again, and these kind of things, right? So, and so we can actually also refresh recursively, and this will go down and refresh the users directory, and just so it's more efficient, so you don't have to click all the time. But you don't want to do it for the drive. Or maybe you do for the drive, because it will take a lot longer because it does all the files. So yeah, so usually I go 1 or 2 levels and I do recursive. Right? But then we can basically search through here, and then we can go to the downloads and look at all these different files. This is what we just downloaded now, and then you can look at any of those files, and then down here you can see some timestamps and things like that, and you can collect them as well. So we before we just looked at the directory listings, and then we can just collect it. So we basically fetch the file. So when we collect the file, we've got little floppy disk thing in there. So it means that the server has the file cached, right? So then we can download it again or whatever, right? And we can look at the text view or the hex view. You can look at the data. Sometimes it's quite handy to just look at a file quickly. And a lot of DFIR is about there's a file on that machine, let's go look at it, fetch it. So you can actually So this is what these top level things, they're called accesses in Velociraptor, which is basically how we're accessing the data. So the auto accessor will use the APIs to just like list directory APIs. But if a file is locked, then it will automatically switch to raw NTFS parsing to fetch it, for example, right? Because a lot of the time, we need to get the end user dat or some registry hive or whatever, and it's locked, so we can't really read it using APIs. So Velociraptor is smart enough to just go, hey, I can't read it. Let's start to parse the NTFS and just extract it sector by sector, off the disk, right? So we can bypass all the locking restrictions. And then, because it has a built-in NTFS parser that we can do like forensic analysis of NTFS at the NTFS level, and we can get those files anyway. And then you can actually just use the NTFS parser directly here to do this, to just do the same thing, to access the file from the NTFS level, and then you get the extra all the extra stuff. For example, the MFT. So we have like some these are all the built-in NTFS files, the boot record extent. So these are like hidden NTFS type files that you can only access through the NTFS parser. So like alternate data streams and things like that. All right, so that's already gives us a lot of capability, right? This is like an interactive capability, and there are a lot of DFIR tools that give you that capability, and then they stop there, right? So if you wanted to go and do some investigation, you could go out and interactively get those files and fetch them, and that's pretty basic type of capability. But the reality is, let me just I just want to make sure I didn't forget to talk about something. So I'm just going to just resync to the flight. So you can also recursively download all the files in a directory. Just showed you how to do that. And then using the NTFS, you can see there's a little bit of highlighting in the UI to show you potential time stomping, which is kind of some heuristics that it uses about times that are birth times that are later than other times, but they're not very good heuristics. So it's not super reliable, but sometimes it helps to just highlight it in the UI. So, but you can only see that in the NTFS analysis. I don't know if I'll show you that real quick. But usually in the NTFS part of the UI, because we're doing NTFS analysis, right? So we can pull out, like let's say this file here, and oops, let's do that. So you can see that there is in NTFS you have different streams and different timestamps, and so some heuristics around where times are kind of like weird. So they'll go like if the birth time is after the M times, and the M time can't be like before it, right? So that's weird. It could indicate time stomping, or it could just indicate sometimes when people unpack something from an installer, then it adjusts the timestamps. So it's not necessarily malicious, but it means the timestamps were adjusted. But that's not always malicious. Sometimes timestamps are adjusted, usually by an installer. So that's kind of cool, right? But clicking around the UI is very intuitive, and it's usually the first level when someone uses Velociraptor. They're like, oh yeah, cool, I want to do IR. I'm just going to click around, find my file. That's great. And it's usable and it gives you the right thing, but it's not the best way of using Velociraptor, because it's kind of a pain, right? You have to find it, you have to find where the file is, you have to know where it is, you have to look at all these, interactively find these things, download them. So what we really wanted to do in Velociraptor is to automate a lot of this stuff, right? So it's kind of like Explorer now, but Explorer is great, but you have to automate it. You have to kind of script these things, and what we really wanted to do is have the ability for this automation to be shared between people, so we can have like a community of people who contribute these what we call artifacts. and have it fully automated. And we can do that by having a query language. So Velociraptor really underneath is using a query language called VQL to actually do all these things, right? To do a lot of the everything, right? Essentially, that's all it does is using VQL. So using VQL, we can quickly change the type of analysis that we can do to the endpoint, and we don't really need to recompile the endpoint and push it. I mean, so there's like a bit of a limit. Like obviously, if you want to add something a more complex feature, you have to have a later version. But for a lot of general features, you can tweak the VQL, tweak the query, change things around, and just write a new artifact, and you can use the same client, just do a different query and get new results, which is really cool. So the idea is that, for instance, most of the time, if a new IC is released, then we can write a query and then just immediately write the query and then hunt it. And so we can really kind of iterate through that in minutes. Sorry. And then we can share those VQL artifacts. So I've got here a link. So over here, page not found. Oops. The link is out of date. So this is our documentation site, docs.velociraptor.app. And over here we have something called the Artifact Exchange. The Artifact Exchange is a place where people contribute artifacts, and then we can exchange them. For instance, Windows error reporting. So someone had written an artifact just recently, a few days ago, to parse Windows error reporting messages to see like which program crashed. A lot of the time malware will crash, and so we want to get that information. And so you can see that Zach Stanford has written this artifact. So over here we've got the query, which is this is the VQL, which I'm not really going to show you too much the details, but really we don't care that much, right, about the VQL itself. What we care about is the name of the artifact, so we can use it, and then a bit of a description tells us what it is, the WHERE files that it's that it's doing, and how to use it. So this is a bit of like human metadata. So we're kind of like putting together the query with some human metadata, and so this is an example of the artifacts that are sent to the exchange, and we can just use it directly in our server. So for example, like Zach sent this artifact called to parse WHERE files, and we can use that directly. So we can actually go into our server artifacts, and then we can import in one step. We just click this import artifact exchange and launch it, and then at once we're going to import all of these artifacts. So what is an artifact? Probably went out of order here. Let me just back up a little bit. So if we go to the view artifacts page here, this is showing us all the artifacts that are known on a server. If you look at any of these artifacts, they have a name, and then they have some human description, and then they have some query here. This is the VQL. Now, you remember that before I was navigating through my VFS, downloading files and listing files and so on. If I look at collected artifacts, from this client, then you can see that my UI, when I was clicking on the UI was actually generating collection requests. So every time I listed, a directory in the VFS, then it went out and it collected this artifact called system VFS list directory. It's just VQL, just runs on the endpoint. So, and then it basically, the GUI just kind of takes the results of that and munges it into the UI. But ultimately, as far as the endpoint is concerned, it's just another query. It's just another artifact, and you can see the query, the details here, and we've got some VQL and it does that stuff. But basically, everything in Velociraptor is just a query. It's just artifacts, different queries, and you can see how I imported the different artifacts from the Exchange. So here, in this case, I automatically imported all the Exchange artifacts, and I can see the error reporting one is here, and it came from the Exchange. So the name adds, has an Exchange in front of it. This is the one I was just looking at before, right? So now it's now part of this system, so I can use that. So artifacts are kind of like programs, VQL programs that you can just load, and then you can just launch it on the endpoint, right? So the endpoint doesn't need to have the artifacts built in. It does it differently each time, so I can change that and implement new artifacts and have new capabilities, immediately. So over here, I can collect new artifacts all the time. So let me just collect some task scheduler. So a lot of the time, threat actors, they achieve persistence through adding some scheduled tasks, right? So we have an artifact called Windows System Task Scheduler, and it basically knows how to parse these scheduled tasks, right? So you can look at the VQL if you want, but the whole point is you don't have to, right? Like, that artifact parses the right thing, right? So all we have to do is just click launch, and then we'll see that now we're scheduling this collection on the endpoint. And you see it's already finished. It takes like 1.72 seconds. It's got duration here, right? Because the client is always connected. So as soon as you collect it, it just does it, right? And then the results come back pretty quick. So when we collect an artifact from the endpoint, what actually happens is you can see the request that goes out. It's kind of small, but it's just got some VQL that ends up being sent to the endpoint, and results come back. So because VQL is a query language, so like any other query language like SQL or whatever, it comes back with a table of results. We have columns and rows, right? So it's like a table. So basically all the results come back with columns and rows. And in this case, let's just change the theme, because I think it's harder to read. I usually do this one. Let's do a light themes. It's a bit easier. So in this case, the task schedule, it analyzes the scheduled tasks files, which are like XML files, and then and then it tries to pull out certain things out of that XML that are really relevant, like which command is started, and these kind of things. So then we can see in one table like all the scheduled tasks, and hopefully we'll be able to catch like an odd looking scheduled task that could indicate a backdoor type thing. All right, let me just go back to the slides, because I think I'm changing my order. All right, so this is what VQL looks like. It's actually pretty simple language, and the whole point of it is to be very simple and easy to understand. So it's not a full-blown language. Like, we're not going to write an operating system in it. It's very simple. It's just a glue language to glue different things together. So it's not a fully featured language, and it looks like SQL, but there's a few differences. Main difference is that we don't really have tables, because it's not a database, right? So we have something called a plugin that runs things, and we can give it arguments. I'm not going to go too much into it, but just to show you, give you a bit of a taste of it, so you can look into it later on. The documentation is on the website. If you want to develop your own VQL, then it's actually not that hard. And then the artifact file, as I showed, is a YAML file that includes human descriptions and queries. And I've shown you how the collections work. We've got in the UI collection here. Oh, I didn't point out that collections return rows, which just we can count how many rows there are, or they can upload megabytes. So if I look at the table here, you can see that some collections actually fetch files. When I downloaded that file, it actually it still sent one row back, and the row is, it's like the hashes and things, but it also has the file itself, right? So we've got two things that queries can do. All right. So the whole point is to be able to share that knowledge, to be able to share the open source knowledge. So that where parser that I pointed out before, Zach has done a lot of work figuring out how where parsers worked, wrote the VQL, then we can just use his query, right? We don't need to understand now how to parse where files, right? So it's all about facilitating that knowledge exchange where one DFIR expert does the hard work of figuring out the forensic artifacts and how we're going to get them, and then the whole community can just instantly benefit from that. That's kind of the vision, right? That's what we want. And so we also have this concept of trying to get the artifacts to be more high level. Like, why are we looking for where files? Because they're going to tell us about crashes. What does that mean? And having that human description in there to kind of help to explain, how someone should use that artifact in practice, So this is what I was showing you before, basically, where we can see some information about each artifact in the artifact view screen. Okay, and then I showed you how to collect an artifact. We just we just go down here to the collected artifacts view, click the plus, and search for artifact collected, right? I'm not sure if there was any crashes, but since we were talking about the error reporting, we can just do that. Now over here, we have some parameters. This one doesn't take any parameters. Let's find one that does. Then I can show you some of the parameters. So if we look at the task schedule, the tasks, scheduled tasks from before, we can see that the scheduled task can take some parameters. And in this case, we have a checkbox here, also upload. So normally that particular artifact, it parses the XML files, but in case you also wanted the XML files just to preserve them, then you can also fetch them. This is just how this particular artifact works. And then so we can choose, so the idea is that we can customize the way the VQL works using these parameters, and we can change the way that it works to collect the right things that we want. Then we can specify resources. And remember how I mentioned before that we are very conscious about the amount of resources that we take on the endpoint, because we don't want, and some of the artifacts, they can be very expensive. Like if we're going to do a Yara scan across the entire disk, I mean, that's going to take a long time and it's going to use up a lot of CPU, right? And so sometimes we might want to limit the CPU use. So, so let's say we're only saying, well, use 20%. Like, I don't care if it take longer to do it, right? But just don't max out the CPU. So we can do that, right? We can say, just go slow, right? It's really important for some of these artifacts, because we're always competing with, like, we're doing DFIR, but then, the users are still trying to use their machines, and they're going to complain if we lock the machines up, right? So we're always conscious of that. And then sometimes it's in DFIR, it's sometimes easy to over collect or have, because we don't know what we're collecting, right? So for instance, like if we say, we want to grab all the temp internet files, from all the users on this machine. I've had that in a case, right, where the user said, the investigator said, I want to collect all the temp history, all the browser artifacts, right? And normally that's not too bad. It takes like, usually it's, maybe like up to a gig of data or something. It's not huge, right? The temp files and, histories and all this stuff. But it so happened that on this one particular machine that he didn't realize this was a terminal services machine, and there was like 300 users on it, right? It was like huge, right? And so suddenly, like it's collected like 100 gigs of data, right? Like, because it just, you can't predict these things when you're doing DFIR, right? Because you don't know what you are looking at, right? So a lot of the time we have these kind of railguards in place where we have limits on the time of execution of the query and the maximum number of rows and the maximum size of uploads. We try and protect the users from these accidents, right? Because it's difficult to predict, right? So basically VQL is preemptible, so we can just cancel the query, like, oh, it's taking too long, and we can cancel it or whatever, right? So in that case, so this is like how we specify the resources here, right? So when we launch it, you can collect more than one thing at the same time, right? So in this case, we did the error reporting and the scheduled tasks, and yeah, see, it looks like, so this is the Windows error reporting crash report that it's parsed it out. So there's an SVC host that crashed. Yeah, we can go into the UI here, and we can turn off some columns if they're too kind of like wide. So it's pulled out from here, like all this information here about a crash. This is really important stuff to see why did something crash. A lot of the time it's because something's injecting into it and it crashed, and it's pretty cool. So and then we can do things like export it to JSON or export it to CSV, sorry, and we can filter it. All right, so this is basically, we gotta step it up. So we've done that. We can see that some of the task scheduler, we collected all the rows, the upload bytes and files uploaded. So we've got statistics and things like that. Oh, so in this case, because I clicked the button that says that I also want the XML files, so it would have already also uploaded those XML files. So you can just grab each one, or you can go to the artifact collection here, and you can see that this is the overview here. It's got 203 rows, and we've collected 600 kilobytes, 200 files, and then we can say, okay, prepare a downloads package, and it's just going to zip it all up, and we can just grab it. So if you want to export the data, like, yeah. All right. So this is basically just a straightforward. Oh, and when you're running a query, there's a query log, and it's telling us what's going on. So we can keep, when a query runs, it kind of like tells you about things. If there's errors, like I can't read this file, or can't parse this file, or whatever, so you can get an idea of whether there's any issues with running it. All right, so and then I showed you how to prepare the download, and then the uploaded files tab. All right, yeah. So the whole idea with VQL is that it's kind of like a glue language, but then we have some really powerful forensic and other plugins inside that do like really powerful analysis. So imagine like all your tools, your DFIR tools or other tools, right? Instead of having these like one-liner Pythons, they're all high-quality plugins, VQL plugins that have like the best in-breed type parsers, and then you can just put them all together and enrich the data with lots of other stuff, and that's kind of what VQL is, right? So it's just a big. So we've got like NTFS, MFT, USN, globe file systems, all of these examples of really cool, very powerful plugins. We've got different file parsers, Grok, SQLite, and we also have a parser framework that you can actually write your own parser in VQL. So and that is super powerful. Like we can parse link files and like a very powerful parser framework. So we can use our own parser framework to actually implement the parser itself in VQL, which is pretty cool. So then we take all of these queries and put them into artifacts. Now we can run artifacts because Velociraptor is just a VQL engine, right? It just runs these queries. So we can run them in different contexts. We can run it on the client, and that's what we've seen so far. We're just collecting artifacts. But you can also run them on the server as well. and that's useful for doing administration of the server or various enrichments. But we also have event artifacts, which I'm not sure if we're going to talk about today. We won't have too much time, but client event artifacts are a way of writing detections, real-time detections on the endpoint in VQL, right? So you can actually create these detections in real time. And server event artifacts are a way of writing real-time detections on the server. So a similar thing. Yeah, so it's open source, right? So, okay, so there is one, we talked about importing the exchange. So we can just take all of this combined community knowledge and extend the server and so on. And the cool thing about it, I just wanted to show, so searching for files. So let's go through the first exercise. We've got like a few. We might not have time, I don't know. Finding files, right? So DFIR is really all about finding files. A lot of the time we just say, did they have this file on the system? Did the Word documents have macros, files, file signatures, and so on? And the Swiss cheese, the Swiss Army knife of finding files is the file finder artifact. So I just wanted to just talk about a few artifacts, a few select ones in details. But of course, they're all useful, but some of them are more frequently useful. So the file finder. So there's 3 versions of it. And in this case, we're going to use the Windows file finder. But it's kind of like a Swiss Army knife for finding files. So it has a lot of parameters that you can use to kind of control the way that it works in different contexts. So for instance, you can give it, so let's say that in this example, we're going to look for all the executables under the /users folder, right? So we're going to do so if we do 2 stars, that means recursive search, and then we go star.exe, exe. So that is called a glob pattern, this stars wildcards, right? So we're going to do like wildcards and say, hey, search C users, recursive search, star.exe. That's useful sometimes, right? Then we can also add a Yara rule here. So we can say, there's a rule template, and you can add a Yara rule, so we can then search the contents of those files. If we make a hit, we can grab the file, we can upload it, or just calculate the hash of it. Right? I'll just click that, and then we can limit it, by times and so on. So, I mean, it's a generic. There, so we have like a date, time, selected there. So it's a generic thing, and depending on what you're doing, this is like a generic tool that you could use, and you would use it in different ways. Like, the user has, we've got a AV alert that something went on at a particular time. Was it a maldoc? Did the user download it? Let's look at the temp history file between this time and that time. For a Word document between, that might have contained this, Yara rule. That you can see how that's useful. Like, you just use it depending on the situation, right? But then once we do that, then off it goes, and it just runs the VQL, and you can see that how we can use these parameters to kind of control the VQL and decide like what we want to do. And see, it didn't take long. We found 37 rows in here, and we're calculating some hashes and so on, right? So we've got timestamps, hashes, and this is the one, the executable we downloaded now. So you can see this is the general purpose file finding thing. It's useful, right? This is the easiest thing, right? Yeah, so we've done this exercise for all the executables, right? The next one is an example of an artifact that's fully super automated, right? Like I said, so essentially, as you know, it's this SQL eCMD, which is another open source project to document how different applications use SQLite. So SQLite is like a file-based database kind of format, and it turns out that a lot of modern software end up using SQLite as a library. It's just easier than writing your own file format, right? And it's much better. It's quite a good one. So we've got browsers using it, and like lots of things. iPhones use it a lot. These kind of things. And so so it's just the different databases, but they have different forensic usefulness. Like even in the browser world, we have the history, we have the cookies. There are different files, and they have different tables in the file, and they mean different things for forensics. So this SQL eCMD project, which is really good, they're trying to document how to parse these different files and use them meaningfully for forensics. So we can take their queries or their work on documenting these things and write a VQL artifact automatically from that, and then it basically just unleash it on the on the hard drive, on the endpoint, and then we're just doing like a file finding. Whenever we see a SQLite file, we figure out, hey, does that look like a Chrome history file or whatever? And if it does, then we just parse it according to the queries that this SQL CMD project ships, and it just works. So just to show you, like, this is one of the coolest artifacts. So I'm just going to do that on my endpoint here. So if I just search for SQL eCMD artifact, actually it's quite a large artifact because they have tons of queries, right? So it takes a while to load. But I can look at the different parameters, and I think it's got a lot of, these are just the different expressions for where to find these things and how to do it. But most of it is default. If I just launch it, we just leave it as default, then this artifact is gonna search my disk to find common SQLite type things, and you can see here it's found all these different SQLite files, and then it tries to kind of catalog them and figure out what they are, right? And it's going to take a little while, but then in the end, it basically just kind of like it's just fully automated, right? It just parses it and extracts useful, forensically useful information from all of these things. We might give it a second. And the cool thing about it is this logic is coming from another open source project that deals with that. So here it is. Okay, so you can see that it's pulled back 4,000 rows in total, and then you can see here it's parsed the different types of SQLite. So we've got autofill, we've got downloads. So we can see that we downloaded the Velociraptor thing. So it just kind of like fully automatically pulls out the browser artifacts and all this sort of stuff. It's very cool. If we look at the log, the query log, then we'll see like that it has things. So this is just messages that it's telling us, and you can see that Velociraptor tries to open some of the SQLite files, but they're locked because the browser is using them now. So it basically goes, oh, it's locked. So it can figure out that it can copy them off to a different temporary file and then query that instead. So what I wanted to point out here is Velociraptor has techniques to make it more robust than just writing a quick Python script, because in reality there are a lot of edge cases where things don't quite work according to plan, right? So we try and do like strategies to help us make things more robust, right? Yeah, so I've got that, and you can see like we can pull out history, and usually the tables are very wide, and so we can when we look at results, we can filter them out. We can you can like add, remove columns, so just to make it, some of them are not super important. So this is a way of post-processing the table. So for example, like if I look at history, and so this is my internet history, And for example, I was looking for, there's some slides and so on. And I can do some filtering. And this is like a UI feature. Basically look for URLs that contain, I don't know, Velociraptor. Oops. Right, so, and then it just helps me find things a little bit easier. So I'll show you later that you can do better filtering, but in the table, just part of the UI, you can filter and sort and these very simple things, transformations. Yeah, so I'm just showing that, and we can see like there's various things in there. Querying the registry. So we have a quick exercise here about registry. So we've seen how we we can use we can search for files, and that's great. But also it's kind of useful to search for registry keys, right? That's the other thing. We have two types of registry we call accesses, way of accessing the data. The registry accessor just uses the APIs, just the normal APIs to access registry. And then we also have a raw registry parser that looks at the Hive files and pulls out raw files. And they're useful in different contexts. So I'm just going to go through an example of a common use of this. Oh, it's one of my favorite examples. And that is disabled event logs. So event logs are kind of like key, right, in Windows. The event logs are really important, and a lot of systems are all about forwarding event logs, like EDRs or whatever. They're really all about forwarding different event logs to servers. But a lot of people don't know that it's very easy to disable event logs on Windows. And I want to show you how to do that, right? So let's say we can run the event viewer, right? And in this example that I'm going to show, we're going to talk about the event viewer is kind of slow, so it takes a little while to come up. We're going to talk about the Beats client, and Beats is what does it stand for?
Background Intelligent Transfer.
Yeah,
System.
the Background Intelligent Transfer System. Yeah, some kind of acronym. But it really is just about it's a service that downloads stuff, right? Usually it's used for Windows Update, but anyway, it can download anything, right? And you can actually use Bits to download anything you want, right? Any payload you want. And the cool thing about it is that it's a signed service that does the downloading. So threat actors use it all the time to download like their payloads, right? Because it's signed. A lot of systems, allow it because it's used for Windows updates. And so, it's actually kind of it's a favorite one. Anyway, it turns out that there is a log file for this Bits thing, and it's right here, Bits client, there it is, and there is an operational. So this is the log file that's used for Bits. But I'm just going to clear it so that we can see the new events quickly. So it turns out that you can disable it. And MITRE, this is the MITRE attack page that just documents this attack. It's obviously very widely used. And over here I've got a command line just to give you an idea of how easy it is to use. I'm just going to copy paste it. Okay. And all it is, actually I'm going to open another command shell here. There we go. And all it is we're going to tell the Bits admin, we're going to add a new job that says fetch this, let's paste that in again, fetch http google.com, like just the URL, whatever, it can be anything. and as a file and put it on test.ps. This is very typical, like for threat actors. Download my payload, my PowerShell tools onto this thing, and basically because the service is doing that, then it's signed. It just works, right? So, but we use that log file to tell us that, for an alert, right? Usually, a lot of systems will use that. Let's go to the event log, and if we refresh that, so we go refresh, then we should be able to see the job is created, right? And then it's finished, right? So this is telling us there's a download transfer. This is the URL that was downloaded, right? And if you are sitting in a SOC and you're looking at these events and you're like, oh my God, somebody's using this. This is really bad, right? Because that URL, it might go to GitHub or something and download some payload, right? Usually, when you see these kind of events for Windows updates, it's pretty obvious, but that's how we use for detection. But it turns out that you can disable that. I'm going to clear the log again so we can see it again. But this time I will disable the log, right? So I'm going to go disable log, right? That's really all it is. So we just disable the log, right? And now if I have a solution that just relies on event logs and forwarding the event logs, well, it's not going to be able to see it. We're going to do the same thing again, and you'll see that this time there isn't any log file generated because the log is disabled. So if we do a refresh, I mean, it's disabled, it's going to be empty, right? That's all it takes, right? So, your system's owned. Let's say the threat actors own the system, and we're like, we're going to forward all these events, but there's no events because it's disabled, right? So how do we know that's happened? How do we know this? It's like a configuration change, right? So it turns out that when you click this disable log thing, it changes some registry keys, and then again, which ones, someone's done the research to figure out which keys it actually, control this, right? But in Velociraptor, we just want to know, how do we actually control it, right? So what we're going to do is we're going to go over here to our collection. We're going to do a plus modification, and there is an artifact called event logs modifications, right? And you can see that the query knows, where to look, which key, and does some registry keys and reads them and stuff like this. But in the end, when we run this, it's going to basically go through and show us which, you see here we have the channel names, lots of different channel names, and whether they are enabled or disabled. So in this case, let's filter channel name bits, bits, and we'll be able to see. So we have Windows Bits Client Analytics and Operationals. They are disabled now, right? So it already just tells us that's the value of this registry key. So that, again, this artifact knows how to find those keys and what they mean, right? And so now we can use it, right? So we can do a hunt. Let me see, so what are we up to? Yeah, so disable event logs. We can find out using this event logs modification. We can find out the log state, and we can look at all of them. So in this case, we looked at all of them, right? And then we can post filter. But if we look at all of them again, so let's just unset that again. So you see there's a lot of them, right? There's 1,000 rows here, so there's a lot of event logs, and you can see that a lot of them are disabled by default, right? So how do you know which ones are supposed to be enabled and which ones are supposed to be disabled? Like, unless you have a security policy hardening guide that says Bits Client Operational has to be enabled, and then you specifically go and look for that, okay, so you're going to catch that, right? But what if there's a different attack vector and the attacker disabled a different log thing, and how do you know, right? So what we want is actually, we want to know when something is odd, or when something is like, it's unset and it should be set. So this is the next the next question, right? Like how do we find out what's the baseline? Oh, so we can also be more targeted in collection. Before we collected the bits client, we collected all of them. If we just copy that collection, so click on the little copy thing, then we can configure the parameters and we can filter, we can add a filter on the collection side, right? So for example, that is going to filter the providers on the collection side. So when we launch that, so it's only going to give us, you know, the 2 rows or 3 rows, the 3 rows, right? So this is showing you the different types of approaches. Sometimes we can do the filtering on the endpoint and get less data. Sometimes we can get tons of data and then do post filtering. So there's 2 approaches: to collect more data or collect less data. So they're both valid and both useful in different contexts. We could talk about that a bit later. Being more targeted means filtering more on the endpoint and being really targeted, because it means that those signals, they are much higher value, come back because we are very targeted. So we can post-process. Showing you how to filter. We can run VQL on the notebooks. We can post-process that, but I really want to get to this point where we're doing hunting. So let me quickly show you that. So now we're collecting from one endpoint, right? And it's fine. We can get that idea interactively, but in this case, what we want to know is what is normal across the network. What is, most people, they have a SOE and they deploy it, and they might have 1,000 machines all set the same, right? And when you don't have very clear policy of what should be the correct, thing, so you can tell whether something is anomalous, then another really good way is to say, well, hey, 10,000 machines have BitSlow client operational enabled, but these guys, are disabled. What's going on, right? Something's weird. So that's also another way of determining anomalies. And I just want to show you this technique. So let me just go back and re-enable that log real quick. So I'm going to enable it. So this is how it should be, right? That's the baseline. So what we want to do is we want to collect the baseline by collecting it across the network. And so we can use hunting. So what does hunting mean? Hunting means that we're collecting that artifact, but not just from one endpoint, but automatically from large number of endpoints, right? And then we can use 2 different approaches. The first one is a detection hunt. And a detection hunt is when we are very targeted. So we know what we're looking for, and we're just running it and we're collecting that from everyone. And then we have a really good idea about whether a particular result comes back with yes or no, and we immediately know that's a problem, right? So an example of a detection hunt in this case would be, let's look for all the machines that have bits client operational disabled. We know that's bad. We're going to be very targeted about this thing, and we're going to collect it from all machines. And immediately, as soon as a machine says, hey, it's disabled on this box, we know that's a problem. Let's look at that. So this is hunting for detection. The other approach is hunting for baselines, where we don't know what's good and what's not good, and we're just saying, let's collect the baseline and then try and do some post-analysis on that and figure out, like, hey, this is anomalous, it might be good, might be bad, but we don't know, right? So there are different approaches. So we're going to do that example. So just to give you the feel of what it feels like to do to do hunting, we're going to start up 100 clients. So Velociraptor has a tool called the pool client, which starts up 100 different clients, like in different threads. So we use that for load testing, but it's a really good demonstration tool as well. So let me run that now. Okay. Sorry. So let's just take a look. So we're going to run Velociraptor, but, oops. Oh, hold on a minute. So normally the client when we run Velociraptor GUI, we are actually running it in the temp file, which would be app data, local, temp, yep, client. Which would, so all the files are going to be in the temp folder over there, and there's going to be a client config over there. So in this case, what we want to do is we want to start up Velociraptor with, you know, that config file. There we go. Copy, paste. So what does this command do? We're going to start up Velociraptor. Like before, we've got the GUI running already in another terminal, right? But we're going to start up a pool client. And the pool client is just like one client, but it's going to run like 100 different threads. And they're all separate. So they look like different machines. And each of them will generate new keys and then start. So it's going to take just a second. And whereas before, if you recall, when we search for all, we only saw, you know, the one client. Now we have 100. So it just gives you an idea of like what it feels like to have lots of machines. But normally we'll have, you know, 10, 20,000 machines, right? But you can see that, you know, you can see that you can page through them and so on, right? And to the server, each of those looks like a completely separate client. So we use that for load testing, but they're all just running on the same endpoint, basically. So what we're going to do now is we're going to do that hunt, previous thing as a hunt, right? So we go over to the hunt manager here, which is just, and then we have a similar interface to how it was before. We do a plus, and now we can start a hunt. So again, a hunt is just collecting the same artifact from lots of machines at the same time. So we can put a description, you know, event log, disabled, whatever. And we can run it everywhere. We can put labels and so on. And the same interface. So the same thing. We're going to collect the event log modifications, and we'll just launch it. And you'll see that when we do that, the hunt is in the paused state. So it's not actually running until we, you know, hit the button. Because I wanted people to know that you're about to launch this on 10,000 machines. If this for whatever reason brings down the endpoints, it could be really bad, right? So just have a bit of a think, you know, is that sensible, you know? But I mean, you can just basically click the play button and off it goes. And you'll see down here that it will start to schedule it, right? And then as soon as those clients are finished, they'll complete, right? So it schedules it and then they complete, and that's it. So we've just collected it from, you know, 100 machines, you know, the same thing. So if we click on the clients tab, then we can see, you know, finish. But of course they're all the same. They're all running on this machine, right? So they're going to give you the same number of, you know, results, right? So we've got 101 machines, and at the moment they're all running with disabled, with the log enabled, right? That would be like our baseline, and that's what you'd normally find. Most of the machines in the deployment would be set up normally, right? But now what we're going to do is we're going to, let me just take that down. I'm going to simulate having one extra machine with a disabled log, right? So I'm going to go over here, disable it, so as I did before, and now I'm going to start up, instead of 101, you know, pool clients, right? And so it will actually create another one, and then that one will run the hunt, because the hunt is still active, right? So it will collect that, but this time it will get the different results. This is the way I'm going to demonstrate to you like how to do stacking, right? So back at here. So we have this thing called a notebook here, and a notebook is a way of doing processing using VQL. So when we do a collection, we have all the results, and we have so we can actually run VQL on the server, and we can use VQL as well to process the data in an interactive way. So this is like if you've ever used Jupyter Notebook or Google Docs, all these people can use the same notebook and share their results. And this is a Hunt notebook. So I can look at it and say, let me just make the font just a little bit bigger so we can see it. So what it does is it's going to read the results of what we had, right? So we can see select star from source artifact, and basically this is just the results. It's just reading the results from the disk. But what we can see is that we have the channel name and whether it's enabled or not. And what I want to do is I want to look for all the unique combinations of the channel name and enabled, right? So what I'm going to do, and then count them. So I'm going to change the query count, and I'm going to do a group by, right? Channel name, comma, enabled. I'm not going to go, too much into it, but it's basically like just post-processing type query. And then I'm going to order it by count, right? And so that will show me, and when I do that, okay. So what is it going to do is it's going to group by unique combinations of channel name and whether it's enabled or disabled, and count them. It puts them into groups and counts how many there are in each group. So I get a result like this. Now you can see that what it's showing me here is it's saying this combination, channel name and enabled. Let me just empty some of, just hide some of those columns. That makes it a little bit easier to see. So I'll put them together, and then the flow ID we don't care about for now. All right. So what this is showing me is that the combination of channel name, bit client operational, and enabled 0 only happened one time, right? But bit client operational enabled 1 happened 101 times, right? So we're just basically, without knowing what's the correct setting, we can see that only one machine has that disabled, and then 101 machines have it enabled. That's typically what you'll see when you're doing these kind of baseline-y type hunts. Is there'll be a few machines that will be unusual because they're not the same as everyone else. It's called stacking. So that's a technique called stacking, and we can get quite far in detection using this. This is really useful when we don't know what the proper thing is, and we're just looking for anomalies. So I just wanted to demonstrate to you like hunting, because hunting is really what Velociraptor is all about. It's the only tool out there that allows you to do these kind of queries at scale. Because remember, there are a lot of interactive tools that, like I showed you before with the VFS, that you can go and look at individual files and interact with it. But try and do that to 10,000 machines. You just can't, right? And then try and stack it. And you can see that with Velociraptor, with a couple of clicks, and it only takes a few minutes, and you're able to look at so many machines so quickly, and then build detections from that. This is really the power. So I showed you the pool clients, showed you how to create a hunt, collected all the results, and then showed you how to do the stacking in this exercise, and then showed you how we can do the group by, which is group by is usually used for stacking, and then ordering it, and we can see the anomalies just kind of standing out. Now, how much time do we have, Glenn?
How long will this section take, you think?
Well, we've got a few more sections, so I think we could skip the NTFS stuff.
If we go for, say, another 5 or 10 minutes, and then give everyone time to have something to eat.
Yeah, 5-10 minutes. Yeah. So what I'll do is I'll skip the NTFS stuff, and then just go to the memory artifact stuff, because I think that's kind of cool. All right. So sorry. All right. So memory artifacts. So again, we are not really going to be able to cover, even like 10% of the features, right? Because there's so many different things. But I'm going to talk a little bit about memory artifacts, and particularly Cobalt Strike, because it's kind of like the elephant in the room when it comes to threat actors. So Cobalt Strike is really good, and a lot of the techniques that it uses are very sophisticated and are only found in memory. So we need to be able to do stuff with memory. Now, straight out memory analysis like volatility in practice doesn't really work. I don't know if you guys have ever tried to use it, because it's not really reliable enough and it doesn't give you high enough quality of data. But we can still use memory to do some detections. I've got a little program here called inject.exe, which I use that to test our memory detection capabilities. But all it is we basically have a payload which is like designed to trigger some of the Yara signatures that usually detect Cobalt Strike. I think it might even contain some of the strings from the Cobalt Strike beacons that we got from VirusTotal. So they're actually like samples, but it doesn't run them. It just injects them into the process, but they're not really running. They're just kind of like, in the process memory. But we use that to detect, to test our memory scanning capability. So I'm going to show you really quickly. So we're done with this pool client. So we have this loader, and you can go -h, and basically we choose a PID, and then it kind of like injects the payload into it, and it's like planting it there, right? So that's what we use. I didn't really want to have like proper Cobalt Strike running, but it's close enough. It doesn't actually run anything, but we'll be able to find it when we're doing memory detection. So I'm just going to start the task manager, and we're going to pick a process, just some random process. I don't know, let's say Chrome, right? One of the Chrome processes. Let's say this one, 940. So the process ID is 940. So all we do is we just for this test, we're just gonna tell it inject into this process, right? So it's gonna basically wait a little bit, because sometimes Windows Defender it scans when you run a process. The Windows Defender scans its memory real quick. So if we load the sample, then sometimes we get picked up by Windows Defender. So if we wait a bit, then it's okay. So we just go ahead and do that. And then you can see it basically opened the process, injected it, and off we go, right? So now we've planted our Cobalt Strike, sample. And so now we can talk about some of the memory. This is just what I did here in the slide. So we can scan for the Cobalt Strike beacon in memory. Let's do that. All right. Plus. If I search for a Cobalt Strike, so this one detects the Cobalt Strike beacon in process memory, and it's basically a general purpose Yara memory scanner of process memory. So it basically goes off, it opens all the processes memory, and it can detect any Yara signature. You can change it, but let me just show you the parameters. So over here we can choose to look at certain processes only. We can upload Yara rules. Like, so this is used for when you have like, sometimes we have like 500 rules in a big huge bundle, and so it's easier to download it at at execution time rather than push it with with the artifact. But the default one is set up to find Cobalt Strike. So we're going to leave the default one just because it's for testing, but you can change it to whatever, and you can also whitelist certain executables, right? So that's more useful for I guess you can whitelist certain executables that you might hit. So we're gonna launch it, and it's gonna take a little while to scan every process. But I just wanted to point out while it's working, I want to show you the log, the query log, and you'll see these messages like this doesn't look at the physical memory, so it's not like a volatility type scan, right? It's opening every process and then scanning it, opening and scanning, right? So we can see that some processes we can't really open because 4 is system process, so we can't open it at all. But these other ones are protected mode processes. We don't have the privileges to open them, and so on. So what we're going to see is it's going to scan the processes, and then some of them it's not going to. So it's not going to detect some of them. But the reality is that protected mode processes, probably Beacon is not going to be injected in there anyway because it's got the same problem. So I'm not too worried about those, right? So it's going to take a little while, and I'm going to leave it off to show you. But I'm going to continue on with the slides because we only have a few minutes. So so we can basically scan the processes with the Yara sig, and we might find the hit. I'm going to show you that in a minute, and we can actually carve out the okay. So this one, Windows Detection Yara process, is a generic Yara scanner, right? So all it's doing is it's saying this Yara scan matched, right? This process. Let's see if we found it yet. I should have restricted it to Chrome just to save time, but anyway, let it run. But once we actually find that process, right? So we might want to actually know something about the configuration of the beacon, because that's useful. It gives us a lot of actionable things, like we know the CNC because we can parse that beacon from memory. Now, beacon is actually pretty sophisticated in obfuscating its configuration in memory, and it's very aware of like trying to make it harder to parse. But Matt Green has actually created, which also works on Velociraptor, has actually recreated some of the parsing capabilities to extract the config, the Cobalt Strike config, using VQL. So VQL is quite powerful, has a quite powerful parser, and Matt Green has actually implemented that, so we can extract the Cobalt Strike config once we found the hit. So this is a slightly different artifact that is very specific about Cobalt Strike and parses it. So I'm just going to quickly show you that. While this is going, I guess. And it's this artifact here, the carving one. And what we're doing is we know we are carving memory for the specifically Cobalt Strike. So not just general Yara, but specifically Cobalt Strike. And just in the interest of time, I'm just going to, I know that it's going to be, in Chrome, so I'm just going to restrict it, but there's actually lots of Chrome processes, so maybe it wasn't that great. But it's going to try and decode that config. And it works for a lot of versions of Cobalt Strike, not all versions, and again because the config is a little bit different, but just to give you guys, I'm just going to show it real quick. It's a very complicated artifact, and this is the parser, that he's written for the config. It's a fairly sophisticated parser as well, and it supports lots of different options, all the different Cobalt Strike options, and it's a pretty sizable VQL, artifact, very sophisticated, right, to do that. But it works, and it works well, and I think Matt's actually used it on engagements and found the CNC, and that's really awesome because you can pull the CNC out of memory and you can go, hey, immediately block off the CNC for that, and then whilst you're doing the IR, so it's actually quite good. Oh yeah, here we go. So that one's finished because it's a bit quicker because we restricted it. So if we just look at we didn't find anything. Oh, maybe it didn't find anything. Was it on Chrome? Oh, the first one's finished it again, but it didn't find anything either. Oh, maybe we didn't look for it.
It said it failed to open 940.
It did find it?
I thought it said it failed to open 940.
Oh, it failed to open 940.
Oh,
904. And we did 940, right? But we got 0 rows. Let me see. We can inject it into something else for now. Let's do it real quick. What do we do? Explorer 6. What do we got?
6848.
6848. Six, 8, 4, 8. Then we're gonna maybe try and restrict it. All the demo gods. Try that. Where are we? 8. Oh. No. Configure parameters. Explorer. There should be a lot less, so it should be a bit quicker, I hope. We could have just gone with the right PID. Oh, here we go, we found it there. Alright, so this is an example. It's just showing you how it found the sample in the Explorer one, and you can see how it breaks up the config and shows you all the different parts of the Cobalt Strike config. So the beacon type, the port, the keys, and this is the C2 server. So it's showing you that's what you need to block on your perimeter if you can, and this user agent, and Cobalt Strike has a malleable config, so you can change. It changes a lot of the indicators that you can use to trap it. So there isn't really a constant indicator. It's all configurable, and it's very hard to detect it otherwise. But if you have all the information about this particular threat actor's configuration, then you can use that to break it, to really detect all the all the infections everywhere, right? So this is really important, right? Tells you about this is telling you how it's executing. It uses that to spawn to, so you can detect that in EDR, process execution, and so on. So I just wanted to show you this because it is such a cool artifact that Matt has written that is really sophisticated in being able to detect these very, very difficult to parse configuration. So finally, we're just going to wrap up. So what did we not cover? There's so many different things. There's a lot of capability in Velociraptor. Event logs, ETW, WMI, eventing, and more. And we didn't cover any of that, but the real strength comes from putting all of these things together in new ways. And we didn't even talk about the monitoring. I just mentioned it briefly. Remember when I said client event artifacts, that we can write real-time monitoring for things on the endpoint, but we didn't even cover it, and automation and all these things. So what I want you to take away from today, it's open source, right? You can use it now, you can play with it. It's really useful for large networks at scale. Being able to write a VQL to try and standardize the way that we collect artifacts. You can also use that to collect interactively from script and things like that. But the dream is that VQL becomes an interchange format for being able to code up a lot of these DFIR things. So you don't end up with these odd Python scripts and Perl scripts, which are not easy to maintain and difficult to write, right? So we want to kind of have a tool that has all this basic building blocks, and then give the DFIR analysts these building blocks so they can put them together and get new detections, into it. These are all the resources here. The doc site, which we talked about before, it's up here. This presentation is going to be on there as well. So and many other presentations as well, and all the videos are there on the site as well. So you can go back and look at it later on and work through it. We also have Discord, the Discord server. You can see it here in linked from the main thing. And we mostly hang out in Discord. So if you ever using it and have a question or a problem or need support or whatever, just jump on the Discord. Community will help. I'm always there. I'm happy to help and talk to anyone and listen to suggestions. And it's just a cool place to hang out. So, by all means, I'd like to see you there. And we have a mailing list. So yeah, thanks very much for listening. And
yeah, thanks, Mike.
Yeah.